Good morning, everyone. So today we will be tackling about the naming of compounds, which will be our last topic for general chemistry. Let's start. Systematic naming of compounds. So we have to know that there are different types of compounds in our daily lives. We have binary compounds, ternary compounds, and there are also quaternary compounds. So when we say compounds, again, it's a combination of two or more elements or atoms combined through chemical bonding. Binary compounds are compounds which is composed of two elements. So we have here are the different major examples of binary compounds. First, we have the binary salts, the binary acids. The nonmetals are the molecules which are composed of two nonmetals, and we also have hydrides. For ternary compounds, these are compounds which is composed of three or more elements. Most of the time, there are some compounds, ternary compounds, which has four um, elements altogether. But we have to consider the fact that there are polyatomic ions, which are one is a cation and the other one is an anion. Okay, but they are already compounds and they are combined together, thus forming ternary or quaternary compounds. So examples of which are ternary acids and ternary salts. Right now, we will be focusing on how to name these different compounds. And I hope that throughout our lesson, you'll be able to understand how we will be able to name each of the examples given here. Okay, so binary compounds are very common and familiar to all of us. So we have, like, for example, H2O or water. It is made up of two elements, hydrogen and oxygen. And we also have the salt, which is sodium chloride, the combination of Na and Cl. And we also have our silicon dioxide, which is most of the time can be found in our sand, no, sa mga beaches natin. And we also have hydrochloric acid, which can also be found in our stomach, which helps us in our digestion. And we also have the nitrous oxide, which is found in our fire extinguishers and can extinguish, of course, fire. So let's proceed to our major examples of binary compounds and how we systematically name each of them. First is the binary salt. So when we say compounds, which is a salt, it is compound containing a metal and a non-metal. Okay, so that's what you need to remember. It is always composed of a metal or a cation and a non-metal or an ion. Okay, so for metals with fixed or unchanging oxidation numbers, so class, what you need to remember again, you have to be guided by your periodic table of elements in order for you to determine whether that specific metal in binary compounds have fixed or unchanging, meaning isa lang siya ang iya oxidation number. No, so like for example, we have here beryllium. Beryllium is a metal. It has only positive 2 oxidation number. And that is what do we mean when we say unchanging or fixed oxidation number? Okay, may isa lang siya kabilog. So the general rule that we follow in naming binary salts having metals with fixed oxidation number is to name the cation first. Okay, so you have to name the cation or the positive ion or the metal or the element that carries a positive charge. Okay, and then name the stem. No, name the stem. So sa aton nga mga elements, we also have syllabication. No, so when we pronounce their names, no, we also syllabicate Okay, so the same with our names. For example, mine is Goldie. No, so there are two syllables, gold and E. No, so Goldie. So that's the syllabication of my name. So sa aton nga mga elements, there are also no syllabication. So name the stem or the root no of the negative ion plus no so i-add mo siya sang suffix or sa aton pa in Tagalog that's hulapi nung ginasugpon mo bala sa iya. Okay, so that is IDE. Okay, so this is always constant. It is already given. So you have to name the stem of the negative ion and just simply connect it with the suffix IDE. So we will go to our example so that we can apply this specific rule. So here, no, we have metals which has fixed oxidation charge or number, like magnesium. So si magnesium, it has positive 2, no, which means may isa lang sa kabilog ng oxidation charge. And we also have bromine. Bromine is the negative ion, which is, of course, a non-metal. So what you need to remember again, in binary salts, which is a binary compound, it is made up of a metal and a non-metal. Okay, so for this case, no, magnesium is a metal which has a fixed oxidation number. So we will follow the rule in naming this specific nga binary compound or binary salt. Okay, so again, no, through crisscross method in terms of their oxidation numbers, no, so Mg plus 2 or positive 2 and B or negative 1. So when you crisscross their oxidation numbers, so one of which will be the subscript of the other, it will become Mg. No? So one na di siya ang iya ni Mg from bromine's oxidation number, and then we have Br or bromine, no, and ang iya subscript is from the magnesium oxidation charge. So if you try to recheck it in our algebraic sum, no, so it will be equal to 0. Okay, so amo na siya class nga ang aton nga chemical formula this time is MgBr2. So let's name it. Let's follow the rule. So first is going back to our previous slide, no? Name the positive ion first. So just simply name it. So what is Mg? That is magnesium. Okay, so magnesium na siya. And then of course, name the stem of the negative ion. So anong stem ni bromine? Okay, so that is brom in. Okay, so that's the two syllables, no, in the name bromine. So which means brom is the first syllable, and that's the root word or the stem of the name bromine. So we have brom, and then we just simply connect it, no, with the suffix IDE. That's why it became bromide. So our name for MgBr2 is magnesium bromide. I hope that's clear for everybody. So that's how we name, no, our binary salts, which has metals having fixed oxidation charge. All right. Next is let's proceed to letter B or another rule, especially for binary salts having variable, now having metals with variable or several oxidation number. Magkambal ka di sang several, meaning damo siya. No, and again, we have to take our guide from our periodic table of elements. So it's very important that you have it with you every time that we have our naming activity. Okay, so that you'll be able to understand that this specific metal has a variable or several oxidation numbers. So like for example, here we have nickel. So si nickel, may ano na siya? Positive 2 pag positive 3 nga oxidation ng mga charges or number. So which means several damo siya. Now the same thing with, we have there si ruthenium. So ruthenium may ara siya positive 3, 4, 6, and 8. So that's having several oxidation number. So if ever you encounter binary salts having this type of metals, you will be able to name them by this specific rules, by the following rules. So we have two rules that we follow in naming these binary salts having metals with variable oxidation numbers. The first method is the old method. So usually, no, ang aton nga mga metals have other names. Okay, so may ara na sila ginhalinan. It's either German, it's from Latin, no, or from Greek nila nga mga names. So that's their usual other name for that specific element. So ang ari nakabutang dere sa aton nga periodic table is their English name. That's the translated English name already, no? But then as you can see, there are some symbols which doesn't literally no talk about no or identify their English name. So like for example, we have Fe. Fe is iron, no? So ang ginhalinan niya na is actually ferrum. Okay, iron is ferrum. That is its previous name. Okay, we also have here copper. Copper is known as coprum. So amo na siya ang iyang mga usual other names, no, for that specific element. But their English translation for coprum, that is copper, and in ferrum, that is iron. Okay, so that's what you need to remember when we are using the old method in terms of naming binary results having metals with variable oxidation numbers. So again, usual other name for the element, or name the stem of the metal, no? And then you just connect it with the suffix OUS or IC. And also name the stem of the non-metal plus the suffix IDE. Okay? So again, name the stem of the metal with the suffix OUS or IC. So class, you might be asking, when will we use OUS or IC? So it will depend, no? Ang aton nga, if you can see that this specific oxidation number, the oxidation number used is lower compared than its other oxidation number, then we will be using the OUS. Again, if it's lower, it's going to be OUS. But if it's higher than the others, no, that will be IC. Okay, so we will be going to apply it in our example later on. So that's name the stem of the non-metal. Again, no, the same thing with this general rule for metals with fixed oxidation number. And then add the suffix IDE to that specific stem. All right, so next is the stock system method. This is the method number 2. So we just simply write the English name of the metal, no? Write the English name of the metal plus enclosed in parentheses the Roman numeral number of the oxidation number. So like for example, no, even before you got the chemical formula, you have to examine kung ano ang original ang oxidation number sang metal nga ara dera. And then you indicate it, no, enclosed in parentheses, the Roman numeral that indicates that specific oxidation number. Plus, again, the name of the stem of the non-metal plus IDE. Okay, so let's take, for example, copper, no, +1. So this is copper. And oxygen -2. So when you crisscross method that one, it will be Cu2O. Okay, so ang aton nga copper, it has oxidation numbers nga +1 and +2. So 1 is really lower than 2. That's the reason why we will make use of the suffix OUS. So as you can see here, no, aton nga copper, ang iya dira nga another term, no, is coprum. So we will be making use of that. No? So it's copper. That is the first syllable for the term coprum. No? So copper, that is again our stem of the usual or the other name for copper. And then we will be making use of OUS nga fixed because again, no, ang iyang original oxidation charge is 1, which is lower than its other oxidation charge, which is 2. And then we just simply write the stem of the next element, which is oxygen, that's ox, and then just simply connect it with the suffix IDE. So this is the old system. That's going to be Cu2O or cuprous oxide. Okay. Next is we have the stock system method. No, so just simply write the English name of that specific element. So that is copper, and enclosed in parentheses its original nga ano nga oxidation number. Before we have the specific chemical formula provided to us, we have to make sure, no, we have to know kung ano gid ang iya original, no? So ibalik mo siya, i-reverse mo siya. Okay, so which means that if ang 2 nga subscript ni copper here, no, iyan na siya oxidation number originally ni oxygen, kag ang 1 diri ni oxygen is originally the subscript, I mean the oxidation charge of copper. So which means, and it will indicate to us that ang original nga oxidation number ni copper is 1, and we have ox, which is the stem of the second element, and just simply add the suffix ide. That's going to be copper 1 oxide. So this is known as the stock system method. Okay, so hopefully, no, you understand how to name binary salts by first, no, determining whether the metal included or involved has fixed oxidation charge, or it has no fixed or several oxidation charges. We also have another example. We have Cu, which is copper plus 2, and F negative 1. So if you write down that in crisscross method, that's going to be CuF2, or also known as, for the old system, again, copper, that is the stem of the other name for copper, that's coprum. So copper, that is the first syllable, and then we just simply use IC. Why? Because again, going back to the oxidation number used originally, no, that is positive 2, which is higher compared than the other oxidation charge ni copper nga positive 1. Okay, so that's going to be making use of IC. So copric, that is copric, and then of course the stem of the second element, that is fluor, and we have the suffix IDE, so that is copric fluoride. Okay, and also we have here in the stock system method, we have the English name for copper. Again, that's simply copper, and enclosed in parentheses, we have here the original oxidation charge of the copper used in this specific chemical formula, that is 2. And of course, just simply write the stem of the second element fluor and just add the suffix IDE. That's going to be copper 2 fluoride. Okay, so I hope that everything is clear for this naming, systematic naming of the different examples in binary salts. Next, we have binary acids. For binary acids or binary compounds, which is known as acids, it is containing of hydrogen and non-metallic elements. Okay, so again, anything that is containing hydrogen and a non-metal element, that is known as binary acid. Okay, so we have two forms for our binary acids. We have the dry form and we have the aqueous form. So when we have a dry form, of course, from the name itself, it is dry. No, it is not wet. It doesn't have anything to do, no, with a water or water solution. Okay, so the general rule that we follow here is first write the name or the term hydrogen and the name of the stem of the non-metallic element. Okay, stem ha, the same thing gihapon dito, and just add the suffix IDE. That's for the dry form. But when this dry form, when this specific acid or binary acid in dry form was placed, or when this acid is dissolved in water to form an acidic solution, the general rule in naming is hydro. Okay, just simply write the name hydro plus the name of the stem of the non-metal with the suffix IC. Okay, plus the term acid. So that's hydro, name the stem of the non-metal with the suffix IC plus acid. Okay, so let's take for example, we have here H positive 1 and Cl negative 1. So that would become in crisscross method, as we write the chemical formula, that's going to be HCl. Okay, so how do we name HCl? So in dry form, write the term hydrogen, and then the stem of the name of the second element or the non-metallic element, that's chlor. Okay, chlorine. That's the first syllable is chlor, and then we have the suffix IDE. So that's going to be hydrogen chloride. Okay, and also next is we have here H positive 1 and Br negative 1. That's going to be HBr. So first, write the term hydrogen, and then the stem of the name of the non-metal, that's brom, bromine. So brom is the first syllable, so that's the root. And then just simply add the suffix IDE, that's going to be hydrogen bromide in dry form. So when you are going to place this binary acids in dry form into an aqueous solution or a water solution, how do we name it? First, we have to write the term hydro. So for HCl, that's going to be hydro. And then the stem of the name of the non-metal, that is chlor. And then just simply add the suffix IC and the term acid. So that's going to be hydrochloric acid. And then we have the HBr. So the hydrogen bromide, when placed in water solution, that's going to be hydro. And then brom is the stem of the non-metal, and then the suffix IC, and that is going to have the term acid. So hydrobromic acid. Okay, so in aqueous form, or when you place hydrogen chloride in water, that's going to be hydrochloric acid. And when you place hydrogen bromide in our water solution, that's going to be hydrobromic acid. I hope that's clear for everybody. So now let's go to our non-metal plus non-metal. So these are molecules, which is also known as binary molecules. So these are binary compounds containing two non-metallic elements. So we will be using Greek prefixes, to indicate the number of atoms in each element present in a molecule of a compound. So the different numeric prefixes that we have is that for 1, that's mono, 2 di, 3 tri, and 4 tetra, 5 penta, 6 hexa, 7 hepta, 8 octa, 9 nona, and 10 deca. Okay, so let's have the rules in systematically naming our compounds or molecules having two nonmetals. So first is name the positive element. So class, when we are talking about non-metals plus non-metals, we are talking about covalent compounds. So ang covalent compounds naton, di ba may natawag kita nga polar covalent bond, wherein one of the non-metal will become partially positive and while the other will become partially negative. So this is what happens, especially in this specific type of naming. Okay, but it also happens in non-polar, covalent bonded compounds. All right, so name the positive element first, then followed by the name of the more negative element. Okay, so that is always the case. and then use the Greek prefixes listed to indicate the number of atoms of each type of element present in the formula of the compound. So you have to know first, you have to look at the subscript, no, for each and every element in the compound, which is composed of two nonmetals. So you have to again indicate the number, no, of atoms of each type of element present in the formula of the compound by using the Greek prefixes as listed earlier. So the prefix mono is often, meaning one, is often omitted when it applies to the first element in a compound. No? So kung ara siya sa first, if one is the subscript of the first element, then we just omit or we do not write anymore the word mono. Okay? So, pero if the second element has one, no, nga subscript, we really write the mono, the term or the prefix mono. Okay, so when we say prefix class, amo na siya sa Tagalog ang aton unlapi, meaning we write that in the first, no, or yeah, before the term itself. Okay, we add that before the term. We also use the suffix IDE for the second element. So the stem of the name of the second element and then the suffix IDE. Okay, so let's take, for example, here. No, so we have P positive 5 and O negative 2. So si P, that's phosphorus. It is a non-metal. Oxygen is also a non-metal. But as you can see, phosphorus here in this specific example is more positive compared than that of oxygen. So siya ang aton isulat una. So siya ang first element naton as stated in our rule. No? So pila, if we try to crisscross method it, that's going to be in the chemical formula P2O5. Okay, so if you try to recheck it algebraically, then we will still have exactly 0. Okay, for the algebraic sum of the oxidation charges. And whatever you add, no, in the algebraic sum naton, then that would become the subscript. But in easier method, no, we have the crisscross method. You just simply have to crisscross, bring down the oxidation number as the subscript of the other element. Okay, so that's going to be P2O5. So the subscript for phosphorus is 2, which means that the prefix that we will be using is di. Okay, so that's going to be diphosphorus. And then the oxygen has 5. So that's going to be penta. Write the stem of the name of that element, ox. And then we have the suffix IDE. So that's going to be diphosphorus pentaoxide. Next is we have CO2. So of course, CO2 is very popular, no, sa aton tanan. And that's 1 for carbon and 2 for oxygen. So that's going to be not monocarbon. We simply omit the 1, no, the mono, because again, if it's going to be written in the first element, no, it's omitted. So that's going to be carbon. And then for oxygen, that's 2. So we have di, and then we have the stem of the name of the second element, which is ox from oxygen, and then we have the suffix IDE. So that's carbon dioxide. For CO, we have, of course, no, 1 for each element. So that's going to be simply carbon, not monocarbon, that's carbon. And then we have 1 also for oxygen, that's monoxide. Now, so mono is 1, and we have the stem of the name, the second element, ox, and then we just simply add the suffix IDE. So class, as you can see, Miss dapat monooxide, no? So if there is a repetition of the vowels, we just simply omit one of them and just simply go on with the term. No, so that's going to be carbon monoxide instead of carbon monoxide. You can still write, in some books you might be able to encounter monoxide instead of monoxide, but in other books naman you can also encounter monoxide only. All right, so I hope that's clear, no, for everybody. We are just simply using our prefixes, no, which indicates also the number or the subscript of that specific element in order for us to name this binary compound, which is composed of two non-metals. Next is we have hydrides. So hydrogen reacts with many metals to form binary compounds called hydrides. So again, si hydrogen naman, no, it reacts with many other metals to form binary compounds, which are called hydrides. These are not called acids. So ang acids nato niya, it's a hydrogen and a non-metal. Hydrides is hydrogen and a metal. Okay, so in this reaction, hydrogen is more electronegative than the metal. It is assigned an oxidation number of -1. If usually see hydrogen has +1, no, nga oxidation number. But for hydrides, ang iya oxidation number used is -1. Okay, so the rule is just simple. Name the metal first and then just simply jot in the term hydride. Okay, so name the metal and just write the term hydride. Okay, so example, we have LiH. No, so LiH is known as, simply write the name of the metal, lithium, and we have the name or the term hydride. Okay, next is we have NaH. No, so that's going to be Na is name the metal, sodium, and then just put in the term hydride. Okay, so sodium hydride. Okay, the same thing with all other metals, which is of course reacting with hydrogen. Okay, so let's go ahead to the next one. Now let's go to our ternary acids, no? So ang acid naton is of course made up of hydrogen gihapon and a polyatomic ion. Magamba kita polyatomic plus is it is also known as oxy-ion, no? So ang aton nga Okay. Ang aton nga ternary acids, no? So again, a hydrogen and a polyatomic ion, no? And it will always depend whether that polyatomic ion ends in the suffix ate or ite. Okay, so where can we be able to know exactly, no, kung ate or ite form na siya? Be guided by your periodic table of elements kay nga aman ara na nada ang aton mga polyatomic anions, no, that ends with ate or ite. You only have to look at them, find them, no, in the bottom part of your periodic table, and you can see there, no, if that specific polyatomic ion refers to having a suffix ate or ite. Okay, so in dry form, ang atong ternary acids, how do we name them? We have to write first the term hydrogen plus the oxy-ion or the name of the polyatomic ion taken from your periodic table of elements. Okay, so like for example, we have here H2CO3. So ang H2CO3, that's the chemical formula. So how do we name that? First is just simply to write hydrogen. This is in dry form. And then write the name of our polyatomic ion. CO3, if you try to locate it, no, that is CO3 with our overall charge na -2, that is hydrogen carbonate. So again, carbonate is our CO3. Okay, so please kindly remember that. Next is we have, excuse me, rule number 2. Ari naman siya yung class, no, most of the time, ang mga polyatomic ions naton, no, it ends in the suffix ite. Okay, so again, just simply write the term hydrogen plus the name of the polyatomic ion in ITE form. Okay, so we have H2SO3. Okay, so see H2 again, that is hydrogen, and SO3, if we try to locate it, no, SO3 with the overall charge -2, that is sulfite. So hydrogen sulfite, that is the name of our ternary acid nga H2SO3. Okay? So hindi ka mo danay magsala diri kung ano ni siya si carbonic acid, si sulfurous acid, no? So hindi danay makadto ta diri danay sa aton nga aqueous form. So here in the aqueous form, no, the negative if the negative ion, no, is in the form of the suffix ate, so kung ang hydrogen carbonate kag hydrogen sulfite i-place mo sila in water solution, no, and if for example we have hydrogen carbonate, it ends with the suffix ate, no, ang nate carbonate, no, so the rule in naming is name the root of the middle element, name the root word or the stem of the name of the specific element, and then just add the suffix ic and the term acid. No, so again, lang tawon tigid kung ATE the end and it is a ternary acid, just simply name the roots of the middle element. Okay, so anong middle element? That is carbon. Okay, so that's the root of the middle element, that is carbon. And then we just simply write the suffix IC, that's going to be carbonic, and then just simply add the term acid. So that's going to be carbonic acid. Okay, so hydrogen carbonate, if placed in water solution, that's going to be carbonic acid this time. Okay, next is if the negative ion is in the form of the suffix ITE. Now, so this time naman si hydrogen sulfite, no? So just simply look at the middle element, that's sulfur. So the rule in naming is name the root of the middle element, so that's sulfur, and then just simply add the suffix OUS plus the term acid. So that's going to be sulfite plus a ITE, that's sulfur, and then OUS, that's sulfurous, and then just simply jot in the term acid. Okay, so sulfurous acid. Paano yung miss kung mag-hydrogen sulfate naman kita? Na may sulfate man kita diri, no? That's SO4, H2SO4. Just going to be in dry form, hydrogen sulfate, no? But if it's in aqueous form, then it's just simply going to be sulfuric acid. Okay, so I hope that's clear for everybody. Next naman is ternary salts. Again, when we say ternary salts, we have the combination of a metal and a non-metal. But for this one, no, we have a metal and a polyatomic ion, no, nga compound na sila ya. This is a combination of two or even more elements which has an overall charge. And again, you can see them naman in your periodic table of elements. No? So ternary salts, first you have to know whether the metal involved is or has fixed oxidation number or unfixed, meaning having several oxidation number. So we have the rule for metals or for ternary salts having metals with the fixed oxidation number. We have name the metal first, name English name of the metal, then name the polyatomic ion. Just simply that. Okay, you have to be guided by your periodic table. Okay, so for example, we have here CaCO3. So Ca, which is of course calcium, has fixed oxidation number, which is +2. CO3, on the other hand, is really known as carbonate. No? So it's going to be CaCO3. So how do we name this specific chemical formula? No? So we have first name the metal, that is calcium, and then name the polyatomic ion as stated in your periodic table of elements. So CO3 is carbonate. So that's the name of CaCO3 compound. Next is we have for metals having variable oxidation numbers. So rule, name the metal first, and then enclosed in parentheses the Roman numeral of the oxidation charge plus name of the polyatomic ion as stated again in your periodic table of elements. Okay, so name of the metal, enclosed in parentheses the original Roman numeral of the oxidation charge, and also name of the polyatomic ion. So how will we be able to know what is the original oxidation charge for the metal? Again, look at the chemical formula. So as you can see here, no, see nickel or Ni, and we have SiO3. So SiO3, no, in our periodic table, that's metasilicate, which carries -2 nga charge. Okay? So as we can see, no, SiO3, ang 3 na ni oxygen is already given, no? Dalayan na iya. So it is not added there at all. Okay? So which means ang gingamit naton nga oxidation charge for nickel is +2. Okay, so like for example, no, kay tungod SiO3 has -2. So if you try to get the algebraic sum for +2 and -2, no, it will be equal to 0. Okay, so which means wala ka na may gin-add nga subscript dara. No? So NiSiO3, that's the chemical formula, which means that in the original, before we have this chemical formula, the oxidation charge of nickel is 2. So we have to enclose in parentheses, no, the Roman numeral 2, and then just simply add there the name of the polyatomic ion, which is metasilicate. So nickel 2 metasilicate. That's the name of NiSiO3. So this is also known, no, in our binary salts kagina as the Stock system method, the usage of Roman numeral numbers, no, in order for us to indicate the oxidation charge of the metal. Okay, so next is we have here compounds containing 4 or more elements. So these are naman mga polyatomic ions or compounds that has been able to interact or combine with each other. Okay, so the rule rather in naming compounds containing 4 or more elements, we have name of the cation first and then name of the anion. Amo lang na siya class, no? So like for example, we have NH4ClO. Okay? So the hindi siya paano to na siya misma identify, no? Just again go back to your periodic table of elements. Okay, so NH4, as you can see in the cation, so cation meaning positive charge ang gina-carry, NH4 is +1. Okay, so that is ammonium. And next is we have to find our anion, which is ClO. ClO is known as hypochlorite and it carries -1. So that would be NH4ClO or ammonium hypochlorite. Okay? So we also have what we call hydrates. Okay, ang hydrates it also contains 4 or more elements. So these are compounds containing water molecules as a part of its crystalline structure. So the rule in naming hydrates, we have name of the compounds first. Okay, so name the compound first, plus the prefix, again, the Greek prefix that we had, and also just simply put in hydrate. Okay, so ang H2O natin is this already hydrate na siya. We only have to indicate the prefix or the number of that, or the how many number of molecules of H2O do we have in this specific chemical formula. Okay, so we have here, no, CuSO4. So Cu is copper. Okay, and also we have SO4. Okay, so this is SO4 is sulfate. Okay, so that's going to be copper sulfate. And then since we have here 5 molecules of H2O, we have to use the prefix, which is penta, and then just simply put in the term hydrate. So that's going to be copper sulfate pentahydrate for CuSO4 5H2O. Or just simply, you can also use this one. Just name first the metal, that is copper, and then we have the polyatomic ion sulfate, SO4, and then just simply write the number 5 and hyphen, just put in hydrate. So copper sulfate 5 hydrate. So that's the name for our compounds containing 4 or more elements. Okay? So thank you very much for listening, and I hope you got everything, internalized everything that we have talked about, especially regarding naming of compounds. If you have any questions, I would be glad to answer it via Messenger. Thank you very much. God bless you.